Okay, can we get started? Good afternoon. My name is Tim Besley. It's a great pleasure to welcome you to this year's Hahn lecture, the third and final keynote lecture of this year's Royal Economic Society conference. It has special poignancy this year since, as many of you know, Frank Hahn passed away earlier in the year. Those who knew Frank have many memories of him, and many of our stories are probably best left for private gatherings. For those of you who never had the pleasure of meeting Frank, it's hard to convey a sense of him. I was once asked to read aloud Frank's tribute to Michio Morishima at a memorial meeting at LSE, and I was tempted to try and imitate his accent, which I would call English country gentleman with a hint of Eastern European. Frank was frequently outrageous and mischievous, but we mustn't forget that he was a leading economic theorist of his generation at a time when mathematical economics was finding its feet. His book With Arrow on general competitive analysis was a landmark, and he believed passionately in the importance of economic theory as a means of enlightening problems. But he also cared strongly about practical issues such as the causes of unemployment. The last time I recall seeing Frank in a seminar was when I was presenting at Cambridge, and Frank came into the room. He was already formally retired by then, and I immediately said that it was a treat to see him, to which he retorted characteristically, "Yes, my dear boy, it's certainly a treat for you." Well, I'm sure that Frank would have recognized that today's lecture will be a treat for all of us, and I know that he would have approved of today's lecturer. Like Frank Hahn, Matt Jackson is a leading economic theorist in his generation. He's William D. Eberle Professor of Economics at Stanford. Matt studied at Princeton and Stanford, followed by spells on the faculty at Northwestern and Caltech before returning to Stanford in 2008. Among his honors, he's a fellow of the Econometric Society and of the American Academy of Arts and Sciences, and he's a fellow in the research program on institutions, organizations, and growth at the Canadian Institute for Advanced Research, something which gives me a frequent pleasure of listening to Matt and benefiting from his insights and comments. He's currently serving also as co-editor of Econometrica. Matt has worked on many big issues in economic theory, such as implementation theory, social learning, and political economy. But his furrow is probably deepest in the area of the economics of social networks. Indeed, I would venture to suggest that his work is the cornerstone of the modern literature and provides structure and unity to what was previously a much more disconnected set of ideas. It's now a central topic in economics, and Matt takes a great deal of credit for helping us see all the wood for the trees. And it's the topic on which he'll be speaking this afternoon. He'll be talking about social networks and economic behavior, lessons from rural India. Moreover, and I can't help but noting that in this work, Matt's adding to the breadth of his research program with an ambitious empirical project, which is what he'll be telling you about. Matt, I'm delighted to welcome you today, and the floor is yours.
So thank you to Tim for that very kind introduction. It's always a pleasure to be with him, but more generally to be here. And as the last plenary speaker, I think we should take just a moment to thank our organizers. So I'm not sure if Phil is here or running around probably taking care of things, but thanking both Phil and Imran here for putting together a spectacular program and a spectacular conference. So let's thank them very much. And just a few words also about Frank Hahn to begin with. So I had the pleasure of spending summers at Stanford when I was in grad school, and Frank Hahn and Ken Arrow and Bob Aumann would organize a set of summer seminar series, and it was quite intimidating to be a speaker in those. I never had the pleasure of speaking in front of that crowd, but when you watch the three of them start to talk about what the speaker was going to speak about, sometimes the speaker wouldn't even finish one or two slides before the discussion would go off between those three, and sometimes the whole seminar would be consumed by the three of them talking about what the speaker should have done rather than what the speaker did do. But it was quite intimidating to watch them dismantle a talk. But in any case, it's a pleasure to be speaking in his honor. So this is, what I'm going to talk about is a project that has been going on for, I guess, about 6 or 7 years now. And the main data gathering exercise has been a joint venture with Abhijit Banerjee, Arun Chandrasekhar, and Esther Duflo. And I'll also talk about a little bit of an offshoot that I've been working on, or has worked on with 2 students from Stanford, Tomas Rodriguez-Baraker and Shu Tan. And in terms of the basic motivation here, the idea is that we are embedded in social networks. Networks influence what information we hear. They influence who we're interacting with, and that's going to affect our behavior. And so if we really want to understand economic outcomes, we have to understand the social fabric that they're embedded in. And in particular, in this set of projects that I'll talk about today, one of the things we're looking at is how access to information and peer influence impact how we behave. And so if we want to understand behavior, how much of what I do is dependent on just being aware of certain things, adopting a new technology, for instance, and how much of it is really being influenced by the people around me. And just to sort of give you a little bit of background on the main part today, we're looking at microfinance diffusion through a series of villages. And when we look at microfinance take-up in different areas, sometimes it's very successful and other times it's not. And for instance, in the villages we'll look at, the minimum take-up was about 7% and the maximum was about 44%. And these are otherwise very similar villages. And so in some situations, people are, eligible households are taking advantage of this availability of loans, and in other villages, they're not. And if you look across the demographics, it's not completely obvious why there would be such a big difference. So it's not clear that there's a difference in terms of the basic demographics between the villages. And so we're interested in understanding why this might occur. And if you're interested in improving things in terms of policy, you want to have some idea of, is it access to information? Is it peer effects? What's keeping people back from participating in some villages, and why is it successful in other villages? Okay, so one thing I want to start with is, when we look at behavior, and often the way peer effects exercises are done is that there'll be some behavior which is analyzed as a function of a set of characteristics and other kinds of the behaviors of peers. So a standard peer effects kind of regression would be something where you'd have behavior on the left-hand side, you'd have your characteristics and so forth, and then you'd have something about a cohort of friends' behavior on the right-hand side, and then you look at a variable and try and understand whether you're really paying attention to friends in doing that. And the difficulty is that there's a lot which gets lumped into this one coefficient, and it's not clear exactly how to interpret that. And if you wanted to take policy to one of these villages and say, okay, look, it looks like people are much more prone to take up microfinance. If their friends do, then we just have to get their friends to do it, and they'll do it. But understanding what's the mechanism by which that works is what we're really after here. So what we're going to try and do is disentangle 2 different effects. So one is just sort of a basic information passing effect. So, am I aware of the product? And in these villages, a lot of people are already aware that microfinance exists in the world. So there's been a lot of press in India, especially in southern India, about microfinance. So the information they need, more or less, is just that there's going to be loans available in their particular village. And so one question is, am I just aware of this? So it's just a fact I have to know. And the second is that there could be some sort of peer influence or endorsement effect. There could be other kinds of reasons that I might or might not do it, even if I'm aware of it. And so, more neighbors taking the action could lead me to take it with higher frequency or even lower frequency. So in these kinds of settings, it could be that if my friends take out a loan, I decide not to take out a loan because I can borrow from them. So you could imagine that what my friends are doing is going to influence my behavior. And what we'd like to do is disentangle these 2 different effects and begin to understand what's going on in the villages. Okay. So that's the sort of micro level. And on a macro level, and some of the original impetus for this project was to try and understand how the network structure and architecture influences the outcome. So If we look at things like the density of a network or segregation patterns in a network, will that influence how diffusion occurs? So if we've got a bunch of different villages and some look more segregated than others, is that going to impact the diffusion? Does it matter what the initial injection or infection points are in a diffusion process? So this is something that hasn't been looked at much in the network analysis, and we might want to know, does it really matter which, if I'm going to talk to 5 people or 10 people in a village, does it matter which 5 or 10 that I talk to, or is it just going to diffuse anyway? I just need to talk to a few, and it's going to percolate through the network. So those are basic, more macro kinds of questions looking at the network, and the other part we'll be trying to disentangle is the individual behavior. Okay. So in terms of outline, what we're going to do is have a basic model of information diffusion about decisions. So we'll have an explicit model here of how people are deciding and how they're hearing about things. And we'll use that to disentangle the peer effects. So how much of this is just being aware, basic information passing, how much of it how much of behavior is affected by complementarities, endorsement, and so forth. Secondly, we'll try and estimate the role of non-participants in diffusion. I'll talk about that as we go along. So there's, often people, when you model diffusion processes, the kind of model that you might use would be something like a flu epidemic, where you think of if somebody adopts something, then their neighbors can adopt it too. If I catch the flu, I can give it to somebody. If I adopt the product, then my friends can adopt the product. But what's different about something like microfinance than a flu is the fact that you could have people who choose not to adopt it who can still be spreading information. And they can still be influential in the diffusion process. So we want to also understand whether these non-participants actually matter in the diffusion process. And then the second part will be this network structure question. How does the network structure affect outcomes? Does it really matter who you talk to in a village in terms of getting word out? Okay, so those are the basic questions that we're after here. Okay, so I'll tell you a little bit about the data that we collected. So we went into 75 villages, and basically we were working in conjunction with a bank that was going to go into these villages and start offering microfinance. We went into the villages before the bank did and went in and surveyed the villages. So we did a census of the households and then went in and surveyed them and asked them about their friends and neighbors and a series of different network questions I'll tell you about. And then collected a whole series of demographics. And then we tracked microfinance participation over time. So we have who took up microfinance at which points in time, and then we basically have a map of the diffusion process. Okay, so the villages were all in Karnataka, so basically within an hour to 2 hours of Bangalore. The villages are on average about 1,000 individuals. They are fairly poor. The per capita income in these villages is on the order of $1 to $3 per day. There's different religions in some of the villages. Predominantly Hindu. There's some Muslim populations and some Christian populations in some of the villages. So there's some diversity across villages. They're largely small rural villages. And we're going to treat them each as isolated communities. So there's occasional marriages between these communities, but very few between the villages that we're actually looking at. So there shouldn't be much contamination from village to village. So the kinds of networks we mapped out, what we looked at, was we asked questions. So for instance, if you had to borrow 50 rupees for a day, who would you go to? So for instance, to blow up this network from one of the villages, these globs of small dots are households, and there's an arrow from one household to another if somebody in that household said that they would borrow 50 rupees from a person in another household. So we have a network of different relationships, and we have 13 different types of questions that we asked. So we know who they borrowed money from, who would you borrow kerosene from, who would you borrow rice from, who would you go to for medical help, who do you go to temple with. So we have a whole series of different questions. This is who do you go to temple with? Obviously not a terribly religious village. And then we have who would you go to for advice? Who comes to you to borrow kerosene? Who would you go to in an emergency for medical help? So we have a series of different questions, and then from this, we're going to use these networks as if individuals who are connected are people who can talk to each other. And so in particular, what we'll do is, for the purposes of today's talk, we'll just take all of the networks together and say that two different households are connected if there's a relationship between them on any one of these questions. So the idea here is really that they can have contact with each other. And actually, you can do much better than the model I'll tell you about by keeping track of how many different relationships they have, and that gives you sort of an intensity. And the more relationships they have, the more likely they are to talk to each other. That's going to add an extra layer to the model that I won't talk about today. But we're just going to treat people as being connected if they said yes on any of these questions. Okay, so that builds us a set of networks in each village. And then we have a series of other questions. So the microfinance participation by individual and time, numbers of households and their composition, whole series of demographics, age, gender, subcaste, religion, profession, education level, families, wealth variables, in terms of the house and so forth, self-help group participation, a whole series of, we actually have lots of caste data. And so we have a lot of backgrounds about the individuals that will help us understand some of the behaviors that are going on as well. Okay, so start with the part one question. What's determining behavior? Is it just awareness of microfinance availability? Or is it complementarities? Does it matter whether my friends are taking it up? Are non-participants important in diffusion and so forth? So we'll model the information passing, and both by participants and non-participants. Okay, so that's the basic structure. And what I want to do is, before we go into that, let's just look at what would come out of a standard peer effects kind of analysis. So let's suppose that what we did was we look at a given household. So just a brief background on the loans here. The loans that were available are loans that were available one per household. So they were given only to women between the ages of 18 and 57 years old. And there's a limit of one per household. So the way in which we're going to work with the data is to treat the household as a unit. And so we'll just look at the household decision. And so we can look at household I. And if we think of the log odds ratio that household I actually takes up a loan, then we'll keep track of their characteristics. So we've got all their characteristics, which are going to obviously impact their decision to take up a loan. And then we can also look at the fraction of their friends participating, for instance, right? So if they're surrounded by more households who take up, does that make them more likely to take up themselves? So this would be one where we could say, am I influenced by what the households around me are doing? Okay. And if you run this regression, if you just go through this, what you're going to get here is a high and statistically extremely significant variable. It says 2.5 here. Let's put that in context a little bit. So that means that if your fraction goes from 0 to 1, so if none of your friends participate compared to 1, then this raises your odds ratio by a factor of 12. So that would make you much more likely to participate if all your friends did. If you just go from 0.1 to 0.3, which is roughly in the sort of standard deviation plus or minus, then your odds ratio goes up by a factor of 1.65. So this would make you think that, my friends are terribly influential here, and I'm really paying attention to what they're doing in determining whether I'm going to take up microfinance. Okay? And what we want to do is break down this 2.5 and sort of understand what's it really coming from. Is it coming from the fact that if I have more friends, I'm just more aware of microfinance? Or is it coming from some fact that I'm inferring something about the microfinance being good for me if I see more of my friends doing it? And those are two very different things. And if we're interested in policy, if all I need to do is be aware of it, it just means that the bank has to do a better job of getting information out. Whereas if there's a peer effect where I'm paying attention to my friends, then somehow we're going to have to educate people and convince them that microfinance is a good thing. So we really want to understand, what does this 2.5 represent, and why is it a positive number here? Okay. So the way we're going to model diffusion is we know these initially. So let me say a little bit about how we know the initially informed nodes. what happened in these villages was the microfinance organization came into each village, and its employee was instructed to go in and find the leaders in a village. And in particular, they were supposed to look for teachers, shopkeepers, and self-help group leaders. So they had a list of individuals in a village that they were supposed to go and contact. And this was usually on the order of 8 to 12 people. They would go into the village, they would find these people and tell them, look, we're a bank, we're going to be offering these loans, they're great for your village. We're going to come back in 2 weeks, so tell everybody you know, and we'll be back here for a meeting, and anybody that's interested can come and sign up in 2 weeks. And then when they came back in 2 weeks, they would sign a bunch of people up and say, okay, and you should tell your friends too, and they would constantly be sort of trying to get this word out, okay? So that's the way it works. And so we know who they actually talk to, who the first individuals that they talk to in the village are. And then we're going to have a model where basically these people are going to talk to their friends, and then their friends can tell their friends and so forth. So we'll have repeated information passing. And then once you're informed, then you can make a choice, similar to the one we just looked at, of whether to participate based on your characteristics and the fraction of your friends who are participating and so forth. Okay, so a very simple model, and we'll just map that out and try and understand, what happens when we model this explicitly. Okay, so the participation choice, again, then, once I'm informed, I make this choice of whether to participate, and then, we're going to look for, am I positively influenced or negatively influenced or not influenced at all by my friends taking up microfinance? Okay. So the way in which we'll do this, again, is very similar to the regression the logistic regression we just looked at. So log of the odds ratio will depend on my characteristics. And here what we'll do in this model now is we'll keep track of the fraction of friends participating, but the fraction of my friends who I've actually talked to about microfinance. So the ones who I've actually had some contact with who are also informed about microfinance, and ignore the people who who haven't been informed about microfinance and couldn't have talked to me about it. Okay. So now what we're going to do is separate out that part from the information passing. And in particular, what we'll do is just have this model where people repeatedly pass information, but there's 2 different probabilities that you can pass information with. One is if I decided not to participate, so I learned about microfinance, and I decided it wasn't good for my household, I didn't participate. There's one probability I pass with. If I chose to participate, I could pass with a different probability. So this is just capturing the fact that if I'm really excited about it, I think it's a great thing, I might go out and tell my friends. If I decided it wasn't that interesting, I'm not really interested in it, I might not tell as many people. So allow this probability to depend on whether I'm participating or not. Okay? And then the way the model is going to work is quite simple. So we know the initial, so take a given village, this is a cut of a network. We know the initial people that were contacted, and we can see which of them participate and which ones don't. So for instance, here, this person chose not to participate, this person chose to participate, and then we start the model in terms of the information passing. So this person can tell their friends, this person can tell their friends, and this person's going to tell people with this probability Qn, a possibly different probability, say a lower probability than this person. So they each tell some friends. If this person's telling with a higher probability, we get more friends getting informed. This person tells somebody, and now each one of these individuals makes a choice. Okay? And the identification we have will come from the fact, well, okay, these people all had a friend who participated. This person has a friend who didn't participate. And now, what choice do they make? So if we can look across, if somebody with similar demographics, this person has one who did participate, this one didn't, then we can tease out what the peer influence is now. So some of these people choose to participate, some don't, right? So they make their choices, and now we repeat that. So then people pass their information again. So a very simple diffusion model. Now these people pass information. This person can still talk to people each period. So there's still communication, and the process just keeps playing itself out. So now we get additional people making choices, and the model continues like that. Okay? So that's the basic diffusion model, and that'll allow us to estimate both the probability that people pass information, as well as how they make their decisions once they're informed. Okay? And so what we'll do is we'll simulate this model starting from the initial points, and we know what the actual participation decisions are eventually of the different individuals, and we can try and estimate the model from the information we have. Okay. So the estimation technique, what we're going to do is basically a simulated method of moments. So we can estimate, actually it turns out to be computationally quite intensive. So we had this, I think, 20 or so servers going at Stanford and at MIT in parallel, and it took us 3 weeks to do one run of the analysis. So what we ended up doing is we can estimate these parameters, the basic parameters from the first regression just on decisions from some of the leaders, and then we go through, and what we did is for each, we basically searched on a grid. So we can search on a grid of QN, QP, and this peer influence variable. We will just divide things into a grid, search for each set of parameters. We estimate the model, so we go through a series of simulations for each set of parameters of what happens in the village, and then we can match the moments of what's actually happening. So what's the fraction of people who end up taking up? What's the fraction of people with certain neighborhoods taking up? What's the variances and so forth? So we have a series of moments, and then we can best match these simulated participation rates and moments to the actual observed ones in the data. Okay? So a very simple technique. We'll just do a grid search and pull these out. Okay. So what did we end up with? So when we do this, these are the estimates you end up with. So QN comes out at about 0.05, highly significant. QP, 0.55, so about 10 times more likely to talk to your friends if you participate versus not. B peer now, this peer effect actually has a slightly negative sign. It's insignificant. Actually, we have more data now that we've collected, and with the additional data, this becomes significant and still slightly negative. So once we've actually separated these things out, what we're getting is the information passing is highly significant and different across whether you participate or not. When we actually look at this, the remaining effect of your peers on your decision, if anything, it might even be slightly negative. So what looked like a strongly positive thing is the reason that we're seeing that 2.5 originally was because if I have more friends around, then and they're participating, I'm much more likely to hear about microfinance than if I have very few friends in my neighborhood who are participating, right? So if I have very few friends, they're passing with a much lower probability, I'm not as likely to hear about microfinance. If I have many friends who are participating, I'm very likely to hear about it. And so what's actually happening is it's just the awareness and the information passing, and the complementarity part is not there. And here we get a highly significant difference between the two, right? So this is very different from what we get if we just ran the peer effects, where you get the same regression will give us a highly significant positive variable. So basically, it's possible to disentangle these two different effects with a simple model, and once we correct for the information passing, we get a very different picture of what's going on in the peer aspect. Okay. So one thing you can do now is we can start to do counterfactuals with the model, and so we could ask how important. These non-participants are only passing with this 0.05 probability. How important are they in terms of the information diffusion in the villages? So one thing we can do is keep everything else constant. And let's suppose that what we did was we just muzzled these people so they can't talk to their friends any longer. We set QN to 0, so now they're no longer passing information. What happens? How much less participation would you get in a village? How much less information would you get if these individuals didn't talk? And one thing to emphasize is there's actually a lot of non-participants in the village, so even though it's only 0.05, a small number, they can still account for a lot of information passing. Okay? And so what we do is if the model, as it was originally with the original variable, 86% of the people end up being informed, around 21% end up participating on average across villages. When you set QN to 0, so if you force the non-participants not to talk any longer and just rerun the model with everything else held constant, then the informedness drops to a little below 60%, and participation drops to a little bit below 14%. So you lose about a third of the information and the eventual participation just by making sure that the non-participants don't talk. So that gives you some idea of how much they accounted for in the actual process. And so they are important even though they're not talking with very high probabilities. So that's one thing that suggests that if we really want to understand diffusion of products, technologies, other kinds of things, we don't want simple contagion models. Keeping track of the actual information passing, even by non-participants, can still be a significant thing to keep track of. Okay, so what do we get from this part of the exercise, the fitting the models of diffusion? Significant information passing parameters, insignificant now and limited sort of peer or endorsement effects. The information passing depends on whether you participate. You're much more likely to talk about it if you participate, not surprisingly. But non-participants still play a substantial role. Okay. So now I want to talk about the second part of the analysis, and the part that actually was sort of the reason we started this, was to try and understand whether the initial injection points and whether the network structure matters. So does it matter who they talk to? Is this all going to wash out? And how should we measure their role? What's a good way of capturing the role of these initial injection points? And one thing to mention here, the model suggests a simple measure of centrality. And let me say a couple of words about this. So if you dig into the social networks literature a bit, there's about 20 measures of centrality that people use on a reasonably regular basis. So if you want to measure how central is a node in a network or how powerful or how influential, there's a huge number. There's betweenness centralities, degree centralities, eigenvectors, Bonasich centrality. I mean, there's a huge list of ways of measuring power or influence or how central individuals are. And one thing that this model does is it gives us a very specific measure of how influential a node is, which is just how much reach would they have in terms of if you talk to a particular person in that village, what's the eventual information flow, how many people in a village would end up hearing about a product if that was the only person you talked to. Okay, so we have a measure that comes directly out of the model, which suggests a centrality, rather than sort of having ad hoc measures, which are off the shelf. So in particular, what we can do is what we define. So now we have 22 measures of centrality. Diffusion centrality, what we'll measure is take a given node I, a given person that you initially talk to, and if they talk for t different periods to their friends, and they talk with given probability p in any given period, how many people do eventually hear about a product? Okay, so that's a measure of how central that person is. So I is initially informed. The initial person tells neighbors with probability p, and then you run it for t periods. Okay. So in terms of operationalizing this, it's actually quite easy to estimate. So what you can do is, if we look at the graph of relationships in the village, is what's known as the adjacency matrix to network people. We just hit that with a p, and if we raise that to t periods, that keeps track of a diffusion run t periods out. So it's a very simple calculation to just sort of estimate, get an expected value for how many people are going to hear. It's not an exact calculation, but this is a good approximation of that. And what happens is if t is equal to 1, so if we just ran this for one period, then basically all you're going to learn is this going to be proportional to how many people I know, right? So if I know 7 people, then how many people I tell is going to be proportional to 7. And so if it's just t equals 1, then this is proportional to my degree. If p it depends on how p compares to the first eigenvalue of the adjacency matrix in terms of whether or not this thing expands at different rates. But in terms of people who study network science, if p is below 1 over the first eigenvalue, then when t is large, this thing approaches what's known as Katz-Bonasich centrality. And if it's larger than 1 over the eigenvalue, it becomes what's known as eigenvector centrality. But basically, what's important here is as you run t to be larger and larger, then you're not just measuring my local neighborhood, but you're measuring what my eventual reach is and how far I get out in terms of eventually having influence on individuals. So it's not only who I'm connected to, but how I'm indirectly connected to different individuals. So in terms of figuring out the importance of these injection points, what we're going to do is the 43 of the villages were the ones that the bank eventually went into, each with its own networks. And we know the particular injection points, and so we can keep track. So the nice thing from our perspective was that even though the bank was looking for teachers, shopkeepers, self-help group leaders, in some villages, those people tend to be really well connected and very central. In another village, those people might be very peripheral. So just by chance, the teacher in village 1 is very well connected. In village 32, the teacher is very peripheral. And so by chance, they are hitting either very central nodes or not so central nodes. So we're getting variation on how central the people they talk to are, and then we can see what the impact is in terms of the microfinance. Okay. So so we'll use our diffusion centrality measure, and we'll also compare it to some other notions of how central nodes are and see what we get. And just to think of other kinds of measures of the centrality, I'll give you 2 other prominent ones. Degree centrality is just counting how many friends you have, right? So in this network, well, this person's the most central, they have 7 friends. This person has 6, they're the most central, and so forth. So a simpler way than using our diffusion centrality would just be count how many friends a person has, and we'll say they're more central if they have lots of friends. Okay. A second way to do it would, well, so why would we want a second way? So let's suppose that we had a network that looks like this. And suppose you have 2 different individuals, this person and this person. They each have 2 friends. Obviously, they're different in terms of their centrality, right? So it's just evident. This person is connected to a person with 7 friends and a person with 6 friends. So they're going to have better reach at a sort of second level. This person has 2 friends, but they each have just 2 friends each. And there's also a sense in which this person is more central in terms of the location of the network. So there's something that we might want to try and capture how this person is more central than this individual. Okay? And that's not captured by just counting friends. So one notion that captures that is what's known as eigenvector centrality. And what does eigenvector centrality look like? The idea behind eigenvector centrality in a network is what you do is you say that the centrality of node I is proportional to the centrality of that person's friends. So I look at that person, and I become important not by just having many friends, but by having well-connected friends. So you just sum up the importance of my friends, and that's how important I am, right? So we get the centrality of I is proportional to the centrality of I's neighbors. Now, of course, this is self-referential, right? So it's just an eigenvector of the matrix of connections, and that's why it's called eigenvector centrality. Okay. So this is a very simple way of capturing the fact that being well-connected is important. And this kind of centrality notion is used quite a bit in different areas. So actually, if you go back to Google PageRank, the way that Google originally chose which pages it would show if you did a query is by keeping track of the eigenvector centrality of different web pages. So it would find the one that matched but also had the highest eigenvector centrality. So that was the way it was listing things. Its algorithm now is more complicated than that, but that was the original. It's also related to what's known as the random surfer model. So if you look on a network and you bounce around at random, following links, and you count the amount of time you're going to spend on different nodes, in the limit, that's going to be proportional to the eigenvector of the adjacency matrix. So what you end up with is a measure that's keeping track of some sort of more important diffusion aspects, and so this might be a better measure than the degree centrality. And the question is also, is the diffusion centrality that we're using, so we've got 3 different measures of centrality we could look at, and we could compare in terms of how well they predict whether a village was successful in terms of microfinance diffusion or not. Okay. When we look back at that network, here, these 2 are now highly distinguished, right? So this one has an eigenvector centrality of 0.331, and this one is 0.11. So it's capturing the fact that this individual is connected to other individuals who have high centrality, and that is capturing something which you don't get out of just counting the number of friends. Okay, so let's have a look at what we end up with. I'll show you with the raw data, and then also what happens when you correct for other village variables. So here, what have we got? We've got the average degree of the leaders, so the average degree centrality, just how many friends on average the leaders had. And actually, you get quite a bit of variation, so it goes from an average of about 12 up to about 20, 27, 28. And then we have microfinance take-up on the vertical axis. So, does the fact that you hit leaders with more friends make a difference? Well, if anything, it's actually negatively sloped and insignificant. So it doesn't appear that hitting leaders with more friends makes much of a difference in getting microfinance take-up. When you look at the eigenvector centrality, it does much better. So it's positively sloped. It's a significant slope. And there's still a lot of variation that's not explained here, but you actually explain about 20% of the variation using the eigenvector centrality. So that's picking up some of the differences across villages, why some villages are down here at 7%, other villages are up here at 40%, 44%. So the eigenvector centrality is beginning to pick that up. And if you do the diffusion centrality, then you also get a positive and significant relationship, and we can actually run a horse race against these and see which one works out. You can do this, if you do the residuals of these on a whole series of other variables to correct for the villages, you basically get the same picture. So it's not, the raw data and so forth are similar. If we run these variables now, the diffusion centrality, eigenvector, degree, if you like your others, there's other centrality measures, closeness, boundedness, betweenness, there's a whole series of them. What you end up finding is, in a bunch of covariates, diffusion centrality is highly significant. Eigenvector centrality is significant at the 90% level. The others are not. And when you run them together, basically the diffusion centrality is the one that's picking things up, and the eigenvector centrality is not. And just intuitively, I think what's going on here is through this simple model, what we're picking up is the fact that people talk to each other a few times, and you want to do it more than once, so you need more than the degree. But the eigenvector centrality is sort of an infinite process. So if you kept bouncing around the network forever, what would the distribution eventually look like? And the diffusion centrality is keeping track of the fact that people talk about things for a while and then get bored of it and stop talking. And so you need something which is actually reaching a few times out, but not an infinite number of times out. And that's what's being picked up here. And so it's actually interesting in terms of the variables that predict the take-up. The diffusion centrality seems to be the one that really tells you why it was in some villages you're getting the 7%, in other villages the 44%. A lot of the other variables that describe the villages don't seem to matter much. And so it's hard to find much other in terms of the explanation besides the diffusion centrality. So hitting the right people makes a big difference in terms of what the outcomes are in these villages. Okay, so part one and part two together, we've got this model of diffusion. The diffusion centrality of the initially informed is a significant predictor of the eventual outcome. So it matters. And one thing we can do is then use the model to see what would happen if we actually change the injection points, right? So now we've got this. We can do counterfactuals and look at a given village and say, let's suppose we hit the best people, the worst people, what's actually going to come out. Now, one side point here. So suppose that you were a bank, and suppose you actually knew the network of the village. And you, after we tell them, look, you want people that are highly central in this diffusion centrality manner, or if you want eigenvector, whatever particular one you want, and you you can talk to 10 people, which 10 do you pick? Well, picking 10 people out of the village, it's not necessarily that you'd want to just rank them from highest centrality down to, because it could be that those people are all connected to each other, and you wouldn't get much reach out of having those 10 people. So actually, figuring out who the best 10 people are in a village is a very complicated problem. And if you map it into computer science, it's a hard problem. I mean, it's what's known as an NP-complete problem. It's a hard problem to solve if you're doing more than one person that you're trying to locate in a village. So knowing exactly how they want to pick things is difficult. So what we did is just pick the 5. If we pick the 5 highest centrality people compared to others, we can do a comparison. But you could probably do better by picking a mixture of individuals, not just the most central people. So if you pick the highest centrality nodes compared to the lowest centrality nodes, then we can go through and what's the participation that you get out on average in the fraction informed. And here you get about 18% if you pick the 5 highest. 5 lowest would give you about 6%. And the fraction informed is drastically different. So basically, going from the least informed to the most, or the least central to the most central people does make a big difference. And so part of the message here would be, the bank needs to figure out how to identify the most central individuals, and that's going to be a policy then that would really change the microfinance take-up. Okay. Well, let me say one more thing before going on this. So let's suppose now that you're the bank and you want to figure out how to identify the most central individuals in the village. What would you do? Well, you could do what we did, which is go door to door, do a complete survey, map out the villages, and then look at the networks, pick the individuals, and then go talk to them. But by the time you've actually gone door to door to do a survey, there's no purpose in actually asking any of the individuals. You might as well have just told everybody in the village. So there's a question of how you identify highly central individuals without being able to actually observe the network. And so one thing we've done, and we've just got the data, we got the data about 2 months ago now, and we're looking at it. From 3 villages, it looks very interesting, is we went and we asked the individuals, if we wanted to get word out about a new product in your village, who should we talk to? And asked people to name the individuals. And then look and see whether the individuals they name are the most central individuals in terms of the centrality. And from the 3 villages we've looked at so far, it looks like they're amazingly good at picking out who the most central people are, not in terms of degree centrality, but actually in terms of either diffusion centrality or eigenvector centrality. So somehow they're internalizing the idea that they have a notion of who are the people that are well connected in the village in terms of getting information out and speaking to other individuals to get information out. So it might be that something as simple as just going in and saying, who should we talk to, would be a good method of getting the information out, and they don't have to have all the demographics and the network data to do that. Okay. One other thing I can mention here, one thing we did is, we've looked at everything just using all 13 networks and one. And in fact, some of the networks are much better predictors than others of diffusion and communication. And so one exercise we've done is sort of looked at, we split things into different villages and different networks. And if you use the ones which involve actual physical exchange of goods, so money, kerosene, and rice, the things that people are borrowing and lending, and you rerun the model and rerun the fits and try and see whether you get a better prediction of the eventual take-up and so forth, you get a complete, so this swamps the other model. So it does much better in terms of predicting than the model with just using all the networks. So it appears that these, using this subset of networks is a better predictor than using also the who comes to your house for dinner, who do you go to temple with, and a bunch of other social ones. These exchange ones are better predictors of the information passing and using in terms of the model. So there's a lot more to be done with the data than we have so far. Okay, just in terms of summary then, we had this simple model of limited diffusion, finite passing. We use it to disentangle peer effects, so basic information passing seems to be significant. The complementarities and endorsement, which look highly significant without this, disappear once you've corrected for the information passing. The estimated role of non-participants, they seem to matter, even though they pass at a much lower rate than the participants in terms of our estimates. So they account for about 1/3 of the informativeness. And the initial injection points matter. And in particular, the diffusion centrality of these injection points seems to be a strong and significant predictor of the eventual outcomes in terms of the diffusion. Now, in terms of the broader messages, I think the network, one thing to take away from this is really that the network information can help quite a bit in understanding exactly what peer effects are looking like. And so we can start looking more deeply inside the black box of peer influence and peer effects. And that has policy consequences. So if you want to understand why kids in school are doing certain things, you want to know whether it's their awareness of things, or whether they're learning from their peers, or it's role models, or peer pressure. There's a whole series of different things that could be mattering, and we need to start disentangling those kinds of things if you want to actually influence policy. And so I think the broader message is not that it's in this particular setting that it turned out to be information and not the endorsement or complementarity, that it's more the methodology, that once you've got the network information, you can begin to study the learning process, the information passing process separately from the decision process, and that can help us understand a little more directly what's going on in terms of peer effects. And the second part, network structures do have consequences here, and the injection points matter in tractable and intuitive ways. And just sort of a last point is that we've been looking at this in rural villages. Technology adoption, even in a very well-networked society, still depends largely on word of mouth. So whether you're aware of new things and so forth isn't always through media and advertising. It's still largely through talking to friends about things and so forth. So a lot of what's going on here, I think, still translates well to the developed world and not just the developing world. So I think that's a good place to stop, and thank you very much for your attention. So everyone right here in the front.
Thanks very much. Could I just, I may have missed it, but could you just have another go at trying to explain more carefully what it is that identifies the micro peer effect? So let me give you the following concerns I have. So even if the initial treatment of the information was random across the village, so both Tim and I both get the information, Tim decides to participate, I don't decide to participate. You say, well, okay, the information Tim gets is better for revealing this information. But say Tim's got a characteristic, unobservably or observably, which makes him closer to you than I am. Maybe he's at Stanford, I'm not at Stanford, or he's a closer neighbor. Right. Won't that cause a closer correlation between your take-up rate and his take-up rate? And it's not so much he's participating because of some other thing, which just makes him closer to you than I am. So although the initial allocation of the information might be exogenous, his take-up is not exogenous. So right. I worry that maybe it's reflecting some further unobservable. Maybe you can condition on the observables Tim has and take that out. Maybe that's what you do, but of course, there's still the unobservable concern.
Yeah, so in the logistic regression, we condition on all the observables. And in fact, if there's a bias, so one possibility is that there's unobservables. And generally in networks, there's strong, people tend to be friends with other individuals who are very similar to themselves. And so if anything, there could be lots of unobservables on which we're highly correlated. So there could be other taste variables that we don't know about that are influencing our decisions. And in that case, if anything, that should make us more positively correlated in terms of our decisions. And so the fact that this parameter is actually coming out negatively is going against the bias that, if anything, these effects should be biasing that to be more strongly positive. Now, in terms of if the identification, part of the way that the identification comes about is, so suppose we look at a given node, a given person in one of these villages, a household, and we look at around them, and actually 5 of the other households around them participate, or half of their friends do. And in another household, it's almost 100%. Well, it turns out that in terms of the information passing, once I've got about 5 households around me that participate, the chance I'm going to hear is almost 100%. Right? So if each one is informing with a probability of half, I'm going to be almost surely informed, as is the other one that has. And so what we can do is looking at those nodes, then differentiate, does it matter that half of the households around me took up as opposed to 100%? And that's where the identification is really coming from. So once you're past a certain threshold, these people are almost surely informed. And then the differences in their take-up rate is what then identifies that parameter of how attentive I am to my peer effects. And so the combination of the model, the information passing, and the decision means you can, it's a well-identified model in terms of getting out both the probability of passing and the eventual decision. Another question. Is Imran? Yeah. So Imran, is it?
So Matt, I just wanted to dig a little bit deeper into the information sharing or information passing idea. So do we want to disentangle the fact that I'm passing on information about the existence of this product versus also trying to persuade people to take it up? And I guess that's important for policy if we think about the nature of information then changing and whether it's possible to, in the model, sort of Q would decay or the opposite of decaying. Or whether we can use information about whether people actually, what they use the loans for, whether it is optimal for them to do so, to understand the nature of persuasion here as well.
Yeah, that's a very good question. And here what we did is we took a very crude cut at things. So basically all we've done is divided into simple information passing of there is microfinance, and then everything else gets loaded into this B peer variable, which is capturing the fact that maybe you try and convince me or you endorse it, et cetera. And so that one variable is picking up everything else. And so ultimately, we'd like even a richer set of models that keep track of not only am I aware, there's just this basic information passing that I tell my friend, but that also they could be learning from my experience and we could be communicating information and separate that out from, say, another complementarity, which is that if my friends take up loans, then it's they're no longer going to be lending to me directly, and maybe now I need to borrow money as well. And now there's no need for reciprocal risk sharing, and so now I'm going to have to borrow myself. So you can imagine a whole series of different effects are going on. And what we've done is just separate them crudely, sort of to basic information and everything else. And more generally, I think we need richer models that begin to tease out different aspects of social learning. Is it just awareness? Is it learning from other people's experience? Is it peer? Is it imitation, role models? What's going on in terms of all the different things? And I think especially when we try and understand technology adoption, other kinds of things, all of these can be at play. And it might be very different, the conclusions you would reach in if you're looking at a high school and trying to figure out why kids smoke or something, than why people are taking up microfinance. But the methodology is basically we need to get better at breaking these models down and looking at the parts. Yeah. Okay. Is there any more?
Thank you. I have 2 questions. So my first question is about the centrality measure. Does a centrality measure depends on the size of the network? And it seems that in a larger network, the degree of centrality will be larger. And my second question is about the characteristic about the village. For example, if a village has a market, And even though you have the same connection, network connection, network structure, but people meet more frequently daily, so it's they got high chances to pass the information.
Sure.
So how does that affect the result?
Sure,
Thank you.
very, very good question. So let me just briefly handle each one. So the centrality measure is sensitive to size of village, and we do a series of corrections. We have a long appendix to the paper, and you can adjust all these things and normalize them for size. And basically the same, as far as we can tell, these are very robust to the size adjustments. The second is, here we're just treating the only information I can get as by information passing. And one thing we've done is we were running a new set of models which actually look quite interesting, which is that instead of thinking of networks as fixed objects and the only conduits of information, think of a link as meaning that I'm much more probable to bump into that person than not. And here we've got 13 different relationships. The more relationships we have in common, the more likely I am to bump into people. But I can still bump into other people. And if there's a market or something, I can still, in these villages, there's only 1,000 people. And if you live there your whole life, you know everybody in the village. So even if you're not connected, you could be talking to somebody else in the village. And so it's more, you could think of these links as higher probabilities rather than lower ones. And if you begin to run a model like that, it actually appears that it does a much better job than this kind of model. So you get improved fit by taking into account that there's other methods. And more generally, these kinds of models, we need to combine them with things like media and other outside influences. But I think that should stop there. So thanks very much.
Thank you. Just to mention Matt for wonderful lecture. I think very well conveyed the excitement of the fact that you're now bringing the theory and the data together in this area. And I think the agenda is a really very exciting one. Thanks for sharing it with us today.
Thanks.